Hello everyone, this is Dr. Feng Wang from my home. Today we are going to start chapter 22, carbonyl condensation reactions. This is a very short chapter for carbonyl compound, and this is the last chapter for carbonyl compounds. We have a big chunk of carbonyl molecules for OChem2. Well, first, the condensation. Condensation means that two molecules work to each other. Normally, a small molecules eliminated during the reaction between the two molecules. For carbonyl condensation reactions, obviously, we have one carbonyl compound react with another carbonyl compound. So we are going to make a bigger molecules during this process again. Normally, a small molecules is eliminated. So let's take a look at the details of the carbonyls, the condensation reaction. The first one is called a Aldol reaction. Aldol reaction, it is a condensation reactions between two aldehyde or two ketones, or one aldehyde and one ketone. Again, Aldol reaction is the condensation reactions between an aldehyde or a ketone with another aldehyde or ketone molecules. So in this case, it is an aldehyde with two carbons here. In base condition, we can form condensation product. Basically, two aldehyde molecules react each other to form a new molecule. This new molecule also has carbonyl groups and plus the hydroxyl groups here. This is called a beta hydroxyl group. Why it is called beta hydroxyl groups? Because we use the carbonyl. This is the center. This is a functional group of the starting material, and also, for the condensation product. So this is the starting point. So the first carbon is considered the alpha carbon. The second carbon is considered the beta carbon. Since the hydroxyl groups is attached here, so we consider this is a beta hydroxyl aldehyde. So this is just a reactant and a product. So let's take a look at the details of this reaction, why we have this reaction. So the first condition is the base condition. We use a base as a catalyst to do an Aldol reaction. Again, Aldol reaction is a condensation between two aldehyde or ketones. So in this case, it's a two carbon. This is the aldehyde molecules. We have a base. We know the alpha hydrogen. This is what we learned in OChem1, chapter 20, probably 21. So alpha hydrogen have some acidity. If we have a base, and the base would react with the alpha hydrogen, alpha of carbonyl groups, to form an enolate. So while we have this acid-base reaction, even sometimes this base is probably not super strong base, is because the conjugate base has a resonance structure. So say this is a carbon anion, negative charge. So it can form a second resonance structure. Basically, the second resonance structure relocated the negative charge from the carbon to the oxygen. That's why we possibly have this reaction from either aldehyde or ketones can do the same reaction to form an enolate. So whenever an enolate is formed, we see that because this carbon bears a negative charge. We know carbon is not a very strong electronegative atom. So this carbon is really mad. I really want to get rid of this negative charge, because again, I'm not really good at dealing with the negative charge. So the good news is we have a second molecule, basically the same with the first molecule. In this case, this carbonyl carbon bears a positive charge. Of course, negative react with a positive charge. So we are going to form this molecule. So that's the condensation reaction. Basically, we linked the two aldehyde molecules together. We are an enolate, and the enolate is formed from the carbonyl compound and the base condition. So the next step is the protonation of this oxygen anion. So either with water or with the acid to form the beta hydroxy. You said this is a beta position. Beta hydroxy carbonyl compound. This is why we have auto condensation reaction in base condition. So the base serves catalyst because in the beginning we need a 1 molar base, and finally we regenerated the base we used during this reaction. That's why base is the catalyst in this process. Well, this is just a product. Beta hydroxyl carbonyl compound is the auto condensation reaction. Normally, this is not a final product, so the reaction will continue. So because in the base condition, we are going to form an alpha beta unsaturated carbonyl compound. So basically, we eliminate water. We eliminate one hydrogen from the alpha position. We eliminate the hydroxyl group from the beta position. So we are going to form, let's say, this is the small molecule. So a condensation molecule normally, the condensation reaction normally involves the elimination of a small molecule. In this case, the small molecule is water, or we call this step is a dehydration step. So we form an alpha beta unsaturated carbonyl compound. So I will explain you later why we normally have this second step, the next few slides. Well, another auto reactions is here. We have a ketone molecule. This is the aldehyde. This is a ketone molecule. The ketone molecule will react to itself actually. The first step is the formation of a beta hydroxy carbonyl compound. So the next step, similar to this aldehyde auto condensation reaction, is the elimination of a small molecule water to form a alpha beta unsaturated carbonyl compound. It's ideally, I hope you are going to, fully understand the whole process. The key mechanism here is the enolate formation. Enolate attack the carbonyl carbon to follow by a protonation reaction to form a beta hydroxy carbonyl compound. But if you want to have a shortcut, some last time after exam 3, some of you told me you need more time to do the exam questions. Here I can share my secret with you. If you have a really short of time to do an exam reaction, here is the secret. So whenever you see a carbonyl compound, particularly either aldehyde or ketones, so you have a base condition. Actually, acid can do the similar reaction too. So the reactions basically is 2 hydrogen from the alpha position plus this is oxygen from another carbonyl molecules from the carbonyl compound, the carbonyl groups. So 2 hydrogen from alpha position, 1 oxygen from the carbonyl oxygen to form water. So you basically link the 2 molecules. You position the 2 molecules. Say this is a 2 hydrogen here. You have another molecule, another ketone molecules. In this case, the ketone molecules provide the oxygen from the carbonyl groups to form the beta hydroxyl carbonyl group compound. This is like intermediate, but the final product is the alpha beta unsaturated carbonyl compound. You see, 2 hydrogen here, 1 oxygen. You see, you used to have a carbon oxygen double bond here, but the oxygen is added to water molecule. Those 2 hydrogen added to water molecule, to the water molecule, 2 hydrogen. That's why we have alpha beta unsaturation here. So this is just a quick way if you don't want to go through the whole process. So this is an easier way, and I hope this will save you some time to do a exam question. So why we have an intermediate alpha hydroxy molecule, then we do the saturation, then we do elimination of water to form a saturated alpha beta unsaturated carbonyl molecules. It's because, you know, this is sp2 hydrogen, sp2 carbon, sp2 carbon, sp2 carbon. Basically, this is a conjugate system from the oxygen to this carbon. There's 4 atoms, oxygen, carbon, carbon, carbon. They all have sp2 hybridization. So whenever they have a sp2 hybridization, they meet actually the requirement for conjugations. So this is what we learned in the conjugation chapter: equal or more than 3 adjacent p orbitals. So each atom provides a p orbitals. So the p orbitals, the electrons in the 4 p orbitals, they move around to form a conjugated system. So normally, a conjugated system will reduce the energy of the whole molecules. So that's why the molecules prefer to form a conjugated system whenever there is a possibility. So remember, I use the Trump Tower to describe the conjugated system, because compared to a small White House, the Trump Tower is much higher, much bigger, so the electrons have more space to play around. So that reduces the energy, and that is also the driving force why for auto condensation reaction, the final product normally it is the alpha beta unsaturated carbonyl compound. So auto reaction can also be catalyzed by acid. So this is the mechanism. I don't think our textbook has this mechanism. This is just the mechanism I came to. So an acid condition, we will not have enolate because there is no base. We cannot depronate this hydrogen here. However, ketone molecules can be tautomerized, form a tautomer, form an anol. You know, this is ketone, this is an anol form. This is an or anol form of the ketone. So the anol form, basically, we have a carbon-carbon double bond here. The pi bond is basically electron rich. I have 2 electrons here. The pi bond, 2 electrons. I'm not very stable. I will attack atoms or groups to which bears the positive charge. So the next ketone molecules here, at acid condition, you know, this oxygen 2 pairs of lone pair electrons. So an acid condition, we can easily protonate this oxygen and form a carbon cation. So in this ketone, molecules, so some of them could be in this enol form. Some of them could be, in this cation form. So if these two will be very happy to react to each other to form these molecules. Well, for condensation reactions, basically we need to rearrange each atom in the two molecules to form the new structure. So it's really hard, to just look at the two molecules and just look at the molecule and draw the structures directly. So my experience from my work is, just to label each atom, label each carbon here, 1, 2, 3, 4, 5, 6. Then we have a 1, 2, 3. When we do this reaction, we do 1, 2, 3. Basically, number 3 attack number 5. So we have a new bond here, 3, 5, because this is a pi bond. Pi bond attack number 5 carbon cation. So number 5 here, 5 attached to 4 and 6. 5 attached to 4 and 6. 5 has hydroxyl group. Number 2 has hydroxyl group because this pi bond, these two molecules forms this bond. So, and in this new structure, number 2 has the positive charge. So, regardless the structure of the ketone or aldehyde molecules, this is a very simple one. So in your exam or in your real work in the future, you may have a bigger molecule than this. How to draw the condensation structures, again, use the numbers. I feel this number is really helpful to decide the structure of the condensation reaction. So the next step, again, this condition of this reactions is acid condition. So we can do water formation. We can do a water formation reaction to form to do the protonation of this oxygen. Okay, deprotonation of this hydrogen to form actually is deprotonation of this. We use the water as the base to deprotonate this hydrogen to form a ketone molecules. So this is the alpha position. This is the beta position. Again, this is a beta hydroxyl carbonyl compound. The next step is the formation of pi bond between the alpha position and the beta position. Is the first step is the protonation of this oxygen forms a good leaving group, and then this leaving group basically is water, leaves this molecule, and this bond, this is the acid molecule. Water serves the base to attack this acid, so we have a new pi bond, alpha beta unsaturated molecules. Again, the driving force for this acid catalyzed auto condensation reaction is the final product, is the alpha beta unsaturated. This is a conjugated system, and a normally conjugated system bears a lower energy. So we have this alpha beta carbonyl compound. So again, my secret in the acid condition is you see the two alpha hydrogen from here react with the oxygen from the carbonyl compound. See, 2 alpha hydrogen. We used to have CH3 here, but 2 of the 3 hydrogen go to waters, the 2 hydrogen here, And we, from the left side, this side, we used to have a ketone carbonyl double bond oxygen. The oxygen basically provide oxygen for the water. So the quick way to know the structure of the final product again is 2 alpha hydrogen plus a second molecule's carbonyl oxygen to form a water, and the water is eliminated during the condensation reaction between the two molecules. A new alpha beta unsaturated carbon-carbon double bond is formed, plus one of the two carbonyl functional groups remain in the final product. All right, so cross-order reaction basically, either aldehyde or ketone, they can react to itself, or they can react with a different aldehyde or ketone reaction. That's called crossed, not only with itself, but with somebody else. So quite frankly, this order reactions, these reactions do not have a wide applications in real-world organic chemistry. The only good application is one of the carbonyl groups has only one of the carbonyl groups. Like, do I have an example here? No, I don't have an example here, because auto condensation reaction is between two carbonyl molecules. One provide alpha hydrogen, another one provide the carbonyl oxygen. If one of the two molecules does not have alpha hydrogen, which means another one, the second one, has to provide the alpha hydrogen. In this case, we have only one product. But if we have two different aldehyde here, like this aldehyde and this aldehyde, we are going to form this product and this product. It's a mixture. So we don't want, for organic synthesis, we will always want to make pure molecules. So if only one of the carbonyl compound has alpha hydrogen, which means this compound has to provide oxygen, and another carbonyl compound will provide 2 alpha hydrogen to do condensation reaction, auto condensation reaction. In that case, we have only one final product. Again, the secret is 1 oxygen from a carbonyl molecule and 2 hydrogen from the second carbonyl molecules. So intramolecular, all the reaction we discussed here is just an intramolecular reaction. Basically, 2 molecules react. However, in some cases, we can have intramolecular auto reactions. Basically, when we see intramolecular reaction, normally means we are going to have 5 or 6 membranes final product. Like in this case, if we have a very special structure, we have an alpha hydrogen here. You see 2 alpha hydrogen and 1 oxygen from the carbonyl oxygen. If this carbon react with this carbonyl group, we are going to have 1, 2, 3, 4, 5. It's going to be a 5 membrane. This is a 5 membrane. You see, this is a carbonyl compound. This is alpha position. This is the beta position. Basically, 2 alpha hydrogen here, because the carbonyl alpha hydrogen here, plus the carbonyl used to be a CO double bond oxygen, is provided by this carbonyl groups to form a ring structure, 5 membrane. This is called an intramolecular auto reaction. By this time we will learn a lot of intramolecular reactions. They normally form either 5-membrane or 6-membrane. These are very unique structures, very unique reactions. Claisen reaction. Claisen reaction is basically similar condensation reaction, but between the two esters. The two ester molecules, they can react to each other. So normally this reaction is catalyzed by a base. So the mechanism is first, we form an enolate. The carbon anion. A carbon anion is going to attack the positively charged carbonyl carbon here, then form a condensation product. The next step is the ketone, the carbonyl groups are regenerated, but the alkoxy oxygen called alkoxy group is eliminated to form the beta ester or beta ketones. If this is a ketone, this is alpha, this is beta, this is a beta carbonyl molecules. So this is not this is the final product, but this is not the final product. This is a very interesting reaction, because whenever we have this product, we still have a base. You see, this is a base. If we have a base, this is the alpha hydrogen. We have 2 alpha hydrogen here. This 2 alpha hydrogen basically is alpha of 2 carbonyl groups. So acidity of this 2 hydrogen is basically pretty strong. So we are going to form an enolate again to depronate one of the 2 hydrogen, form enolate. So the final step is basically the protonation of this enolate to form this beta keto ester, because this keto entered the beta position, and this is an ester. You see, these 2 molecules, basically the same molecules. So that's why I say this is the final product, because of the same structure. But this is not the final product, because when we do the reaction in the lab, we cannot isolate this molecule. We are going to have this molecule that isolated this molecule. Then we protonation of this carbon anion to form this beta keto ester. This will be the final product. So the secret for Claisen reaction basically is 2 ester molecules to react to each other. So one molecule is eliminated. The molecule is basically alcohol. So 1 alpha hydrogen, you see, 1 alpha hydrogen from the right side, CH3, now it used to be CH3 here, now it's a CH2. And one alpha hydrogen plus, actually from the left side. The one from the left side, one of the hydrogen here, CH3 here, turns to CH2 here. So one of hydrogen provide the alcohol's hydrogen or alkoxy groups from the second molecule, the right side molecule. The right side molecule you see here, we have an ethoxylate, O ethyl groups here. So O ethyl groups provide alkoxy part of alcohol. So again, I hope you fully understand the mechanism of this process. But again, if you want to quickly know the answer of the Claisen reaction, basically 2 ester molecules react to each other to form a condensation product with the elimination of small alcohol molecules. One provide hydrogen, another one provide alkoxy. That's the Claisen reaction. All right, that's the condensation reactions of our carbonyl compound, and this is first part of this lecture. And in the next lecture, I'm going to review some other reactions from a carbonyl compound. and take a break, and I'll see you later.